All right. Thank you, everybody, for putting up with that. My name is David Newell. I'm a senior software engineer working at Google on the configuration safety team. And I wanted to talk to you about the interactions between configuration and code, how each one affects the other, and kind of how to measure and understand if the two are working safely together. First off, though, I want to start with a story. So back in 2012, I was living in and working in Manhattan, consulting at a financial trading firm. And August 1st, I come into work at a reasonable time in the morning, and everyone's talking about this company, Knight Capital, that was just down the street from us. And the outage that they just had and how they had just ruined the markets, and everyone asking, could this happen to us? Could we fall into that? And researching this a bit more for this, this is just a comedy of errors. So the New York Stock Exchange came out with this retail liquidity program where the big clients could get a preference. And Knight Capital was one of those and decided we are going to reuse the flag that to turn this on that had only been used about 10 years ago for a now defunct testing program that is still in the code base. And then they go in and update 7 of their 8 servers. Not sure what happened to the 8th, someone just forgot. In 2005, or before 2005, there was a quantity function that could limit how much this testing program did, but it wasn't used in 10 years, so that got removed, but the testing function did not. So whenever they turn this on August 1st at 8:01, they get a bunch of emails saying this 10-year-old program, something's going on with it. It's testing only. It's 10 years old. They don't care. Not a problem. By 9:30, the trading on this retail liquidity program starts, and the 7 servers that were updated work properly, and the one that wasn't, this extra testing thing, PowerPeg, was meant to move the price in testing. So it bought high and sold low, just to keep moving that price until it got to the right point. 9:34, the New York Stock Exchange reaches out to Knight Capital and says, hey, something's going wrong with your servers, you should figure it out. All of 4 minutes. And so, of course, great, just turn it off and we're fine. They didn't know how to do that. So it kept going. Eventually they figure out what the problem is in that it's new, it must be the new stuff. So they roll back the 7 working servers to the code base that has the one bad one. This whole thing lasts about 30 minutes, 30 to 45 minutes. They end up holding on to $6 billion worth of stock across 150 different companies that they didn't really know what to do with. One company I saw in particular, Wizard Software Corporation, started off the day at 9:30 a.m. at $3.50 a share. And then by the end of this, about 45 minutes later, it was trading for almost $15 a share. So 4x jump in price, a little bit more than that, over less than an hour. What happened here? Well, they had some code, and it just fundamentally changed the way their configuration worked. Flag used to point to one thing, now it points to something completely different. But it works the other way as well. The next year, Google had an issue where the code was running. It was a well-used library. No real problems with it. But there was an invalid configuration that started using the library now in a different way. So in one of these, the code changes underneath the configuration, and the other one, the configuration changes how the code is run. But these are both 10 years ago, right? That's not a problem anymore. It's actually kind of gotten worse. Now we have a lot more stuff in the cloud and containers, and you have to configure all of those, and you can change how much memory or what addresses everything points to. And so I'm not exactly sure this drop in 2020, maybe With all the COVID, no one is rolling out new servers, but we'll see if it starts to creep back up again. It grew pretty quickly before. Some recent ones, this year Spotify had an issue. Normal Git maintenance, but while their servers were down, they roll out a new DNS configuration. When they come back up, it's propagated to every server. GitHub had one earlier this year. Configuration incident, they caught it quickly, roll it back. The rollback fails. Cloudflare had one, another network configuration. All of these this year. So this is still a problem. But so how can we measure this? How can we track where things are dangerous and where it's not? Well, in code, we have a set of practices that we should also be applying to configuration. Things like code review and whatnot. But we also have some metrics. Now, if these metrics are perfect, it doesn't mean your code is perfect, right? If you have 100% code coverage, doesn't mean there's no issues. But if these metrics are bad, there's definitely a problem somewhere in there that you don't know about. All right, if you're running around with 5%, 20% code coverage, who knows what the rest of that code is doing? And we can come up with some of these specific to configuration as well. So distance from definition, number of usages. Imagine you have a dry run flag supposed to stop writing to the databases. Well, if you have to remember every time you're trying to write to the database, check if dry run, log, else, write to database, at some point you're going to forget. The engineer who was writing this isn't thinking about the dry run flag. They're thinking, I have some data I need to write out. If we move this all up to the front in your main function, if dry run, fake database, real database, then no one has to think about it later. But also, a lot of these same metrics that apply to code can apply to config if we think about it in a certain way. So I'm going to focus on code coverage. So here's the example we're going to look at real quick. We have this flag connection. It has a couple different types, TCP, UDP. And we can see it's used once. It's used early. That's good. If we add a new one, we just increase the case statement. Probably should have a default, but screen size. Let's say we have a test for the TCP one. Is this flag well tested? Is the code coverage for this flag good? Well, no one would test that var connection equals flag.string. What do you test? How do you even set that up in a test? Yes, the flag exists. Doesn't really protect you from anything. But if we test the individual case statements, then we know we can see here one of them is tested, gives us about a 25% test coverage rate. Not great, we should add tests for the rest of them. And then we can feel good turning this flag on into any of these conditions. It's probably well tested. So how would you do that? Find the flag where it's used. Find the test coverage there. If it's passed into a function, is the body of that function well tested? The return values of that function, or maybe you make an object with the flag, are those well tested? Is the methods of that object well tested? And kind of repeat this to an arbitrary depth till you think, I've actually captured where the flag value is used. All right, if you open a database, I want to make sure that I'm opening the right database, but once I have that, I trust the database library is going to work as it should. So we tried this, we did this. How did that work out? Well, it did. We preferenced telling people only when we were sure something was poorly tested. So we looked at the results, and the ones that we were clear on saying, you should add some more tests here, worked. That was true. But it's kind of hard to parse a language kind of from this side somebody wrote, and now we have to go through and understand, and how far do we test something to know if it's still the flag under test versus some result that no longer needs to be tested. And this was just for Go, which is a fairly simple language in terms of syntax. If you're trying to spread this out, even if you just have front end and back end, trying to apply this to a UI as well, you've got two languages. If you've got multiple back end languages, Java, C++, whatever, trying to parse all of those, it becomes increasingly complicated and just more work. But I was thinking, while preparing for this, I've heard all of this about LLMs being able to parse programming languages, to write tests, to change comments into code or the other way around. So I thought, can it do this as well? How well can it understand the layers of flags and how far they get passed in? So let's find out. So here's the test code. I'm going to paste this directly into the LLM. So scroll by, so take a look now. The only flag we're looking at is port. It has a lower bounds and then gets passed into this make call function where it has an upper bounds, and then we just have a fake even odd connect, don't connect. And then there's a lot of fatals if anything doesn't go exactly right. We have a test for this, but the test is only even odd and only for make call. There's no reference to port here in any way. All right, let's see if, all right, please get a little, that's just going to be fuzzy. That's too small. Okay, well, so I paste the code in here and ask, where's the flag used? Look at the functions it's passed into, look at their return values. Tell me everywhere it's used. It starts off very simple. Good job, it knows the language. Declares the flag, easy enough. Parse the flags. It knows what a flag is, I guess. Direct reference, lower bounds. That's easy enough to get. Make call as well. Again, directly passing in the flag, easy enough, but now it's able to step into make call and understand that port is now renamed outgoing within the function. And it gets the upper bounds and then the fake connection. So LLMs have a fixed amount of space you can for input and output. So sometimes you kind of need to say continue. And so here I ask it, what about the return value? So it keeps going, make call, and then it'll go through all of these failure cases. All right, so it knows that if it's actually connected, it's going to error out, and then a successful message. So now I ask it about the type completeness. Tell me what are the valid values of port. So checking if it can understand all of those conditions that it already told us about. So it gets the lower bounds. It understands the upper bounds, again, being passed in and the name changing. And it understands that it needs to be even. So it's able to catch all of these conditions. All right, and the last thing I ask is, how well tested is this? I paste in the test and say what tests need to be added for this to be well tested. So it reads this existing test cases first. It's worth noting I ask it where the port flag is well tested, and it immediately says you have the even odd tests for make call, and it understands the upper and lower bounds testing needs to be added. Oh, so there's the upper bounds, and then yeah, boundary test for minimum valid port. So this was able to go through, track where the port is used in various functions, understand those functions, look at the return values, kind of parse all of this, tell you what values were useful for the flag, tell you what tests need to be added there. So how could this be improved? There we go. Well, first off, this is very wordy, and it doesn't make a lot of sense to go in every time and sit there and wait for the response and type in, tell me about this flag, tell me about that flag, continue with the return values. So prompt tuning can help out with this to shorten it down into something that you could automate. It's easy to parse flag names out of a file, find the flag name, put it into some template, send that up. Get your LLM to respond in something less verbose so that you can parse that again and have some useful results. But like I said, there's the limit on the input and output for the LLMs. So this would naturally get better over time, but I question, if you have full production level code that you're trying to paste in here and tests and getting passed through multiple files, how well this would still hold up. But at least for a demo for here, it seems to work out. Right? Well, thank you very much. Thank you.
Hello. Thank you. There is a bit of time for questions. Yes, Marcel.
Question that comes to mind immediately using LLMs, how would that scale at the Google code base? Does it, or do you anticipate?
So you can use, LLMs are kind of expensive. This is a nice thing you could do kind of offline when resource usage is low. Mm-hmm. And you might want to do it like on every change, and then it gets more expensive. That's just kind of where you're putting the resources and if this is protecting you from enough to be worth the resource.
So one comment for the first part of this analysis where you see what are the conditions.
Yeah.
I did some analysis for Istio, like very similar, but I used SSA instead. Mm-hmm. And I was able to get like 95% coverage, like from the Go code, getting all the expressions that basically to validate. So to know what the ranges are, what are the valid ranges, what are the valid inputs.
Okay.
Just FYI.
Yeah, good to know. Thank you.
Thank you. Other questions? You okay? No? Nice. Sorry.
So I assume, you didn't mention it, so you probably didn't try an AST approach, like you wanted to try the LLM approach for this. It would be interesting to see if an AST approach, like Marcel was saying, for I imagine it would get pretty good coverage for simpler things if the LLM would be more helpful as the file has more indirection towards the actual flag values from the start statement, right?
Yes. So I did actually use the AST approach, and that's the results that we got. That was actually working. The problem is parsing all of the different ways flags are created and used. And so it's kind of an ever-growing problem.
Yeah.
So it works. It just takes time and effort.
I see. So at that point, the LLM is almost like a heuristic, where it's maybe even simpler computation-wise.
Yeah.
Interesting.
Yeah, I worked on the LLM BART just for this talk, just to see if that would work as well.
That's cool.
Thank you again.